All right, so now what we're going to do is take some data from an API and send it to our microcontroller. So we're going to have internet information controlling these LEDs here. So this is basically the sketch running. We can sort of set and press it and run it again, and we'll see in a second. That and then ta-da, right? So it sends out the information from the sketch to the microcontroller, and I just want to walk you through it. It's taking a lot of the things that we've done so far over the last few weeks and putting them together in a unique way. There's some stuff in here that might get a little bit confusing, just about parsing strings and things like that. It's okay. I mean, you can also refer back to the video where we were just sending one piece of information from p5.js to the Arduino, and that could be a way of doing this as well. So this is a slightly more complex thing, but it's worth a shot trying to figure out. So here on the microcontroller side, I've got NeoPixels, LEDs, this sort of standard setup stuff that we did last week. And then here I've got an array that's going to hold the RGB values from my P5 sketch. So right now they start out as empty, so nothing in there. And then I've got this empty string that's going to hold the incoming data as it comes in the serial port. And then I've got this flag right here that just lets me know whether the string is complete or not. We'll see how all this works in just a moment. So in our setup, we start serial, we start communication with the LEDs, we turn them all off, and then we're reserving some memory for the input string. Now, 50 bytes is way more than we're ever going to need if we're just sending RGB values with a couple commas and spaces, but it doesn't hurt to just sort of like have that space set aside necessarily. We've got this establish contact function right here that basically says like it's basically blocking the program from doing anything until it actually receives until it makes connection and receives data from the P5 sketch. So if we take a look at that again down here, the established data just basically says, while there's nothing inside of the microcontroller serial port, continually send an A out to whatever is connected. Right, so just that roughly 3 times a second, and then once on the P5 side that we'll take a look in a second, when P5 receives this, is connected and receives a bit of serial information, then it suddenly says like, whoa, okay, now it's time to do something, and it'll send serial information. We break out of this while loop and we can go back into the sketch itself. So inside of the loop, this is where we're handling everything. So this gets a little bit like grody in here, but you'll see what's going on in just a second. So while there's serial data available inside of the port, then what we're going to do is we're going to read the data in 1 byte at a time and build up a string with that. And then we're going to parse through the string using using commas as delimiters. So basically we're going to look at 255, comma, 127, comma, 0, comma, for example, right? And so we need to read all this information in, know that we've got a complete set of data where there's 3 values separated by commas, and then we can go and process our sketch. So in here, we read information out of the serial buffer, we convert it to a character, and we store it inside of this variable right here, which is character data type, in character. And we add this to the input string, right? So every time we go through the loop, we just tack in another letter onto our input string. If we read a new line character, then that means we've received a full set of information. So we're going to use the new line character as a flag to indicate that we've got a complete set of data. So if we've got a complete set of data, then we're going to trim any extra white space off of the input string, and we automatically escape out of this while loop because there's nothing else left inside of the serial buffer at that point in time. So if we have a valid string, then what we're going to do is we're going to parse through that string, and that string is going to be formatted. It's going to look something like this. So it would look so in case of this green one, it's look like 250. Right. So this is, for example, the string that we would receive to turn the LEDs green, like we see right now. So what we need to do is we need to parse through this and save it into an array. So what I'm going to do right here, and this is a sort of a generic example that you could use for sending multiple bits of information from p5.js to an Arduino. So let's say instead of LEDs, you wanted to move like, a servo motor, a buzzer, and one LED. This is a way that you could get 3 bits of information and do something like that. So I've got something right here that's basically counting the length of the string, and we need to keep track of that. I've got some other variables here that are going to keep track of, like, as we parse the string, looking for those commas, some other variables to do that. And then this value right here is going to hold a whole number before we convert it into an integer and save that into our array. And then this counter right here just like lets us know which index in the array we should be saving stuff into. So we say basically we've got this do while loop, and so while we have not parsed through and read through everything inside of this string, it's essentially what this is saying. Then what we want to do is we want to find the first comma in the string, so right here in our example, parse that and take the value that's inside that is before the comma, which this is doing right here, and save that into this string right here called value. Trim off any white space because you'll see that like these have like a blank space and then a number, blank space, then a number, right? So this will trim off any white space, and then we store that into our input array. And when we do that, we convert the string to an integer. We increment this index right here to find the next value in whole value inside of our string. We also increment the counter so we can move into the next part of the next index in our array. So this cycles through until we reach the end of our string. And that's really what this chunk of code right here is doing. It's worth looking into the string functions of the Arduino. There's some extensive documentation on it. Uh, it's not as easy to work with strings in microcontroller as it is in, say, JavaScript or Python, but it's still possible. It takes up a fair amount of memory, but with the microcontrollers that we're using these days, it's not so much of a concern. Here, what I'm doing is I'm taking the LED, the colors, those values, and I'm saying like store that into this strip color right here. So I'm saying LEDs.color, and then my red value, my green value, my blue value, right? So we use those to create a new color, and then we send that to all the LEDs. We're saying LED.fill. So if you remember, this is how you fill an entire string of neopixels with one color. And then we show that color. After we've done that, we clear out the input string. So we just erase it and we say, we'll just wait for something new. We set the string complete flag to false. So that means that like we don't enter back into this loop until we've got a valid packet again from p5.js. And then finally, we send out a byte to p5.js saying like, I'm ready for more information if you want to send it to me. So this is just how this sketch works. It's basically like that handshake call and response example that we saw with serial communication, but going in the opposite direction. So here we're sending 3 values to the Arduino instead of sending 3 values to p5.js. So on the p5 side, we've got a variable to hold out the serial data, or this, basically the serial object, sorry. We've got these same things that we had previously, one for holding the whole JSON object, some for the background text color, and then another one just for the piece of information that we want, the AQI value. We use the preload to download the JSON into the sketch, and we parse through that, and we just pull out the information that we want from it. Um, here I can just change this back to that a little bit nicer. Print out the API data, save the AQI into a variable and print that out. And then we go through like a serial constructor. We say, which port to use, what to do when we get data, and what to do when the serial port opens, right? And here we're just like going through, so this stuff we covered in the serial communication examples. Here we're just parsing through the different values that the AQI might be to change the background color and text color. Inside of the draw loop, we're doing the same thing that we did previously. The biggest difference is what's going on here inside of the got data and got open, right? So in got open, we're saying, so once the serial port is opened, then we just say, we just read any value that we've got in the serial buffer, and we're just gonna like print that out into the console just so we can see it. Inside of the got data, this is what gets triggered, repeatedly whenever it's ready to send new information. And here you can say, see, we've got a variable to store the background color. It's called LED color. And so what we're doing here is we're saying, take the background color and then convert that to a string and do that as an RGB value, right? And so what happens when you do this is in p5.js, if we were to print out LED color on its own, said console.log LED color, right? And I'll just stop this and reset this guy here and run it. We'll see this print out down inside of here. So here you can see this is the RGB color right here, right? So when we say this is what gives us the colors out of the background right here. So you'll see that it's a string that has RGB parens, 0 comma space 255 comma space 0 close parens. And so what we want to do is we want to get rid of those parentheses, right? Uh, so here we've got, so I'm just going to comment that back out. So all we're doing right here is we're storing the value as this, right? Right here. Here we've got another variable to just read the byte out of the serial buffer. We don't do anything with it. If you want to, I'm printing it out right here so you can see that like the ASCII value of 65 and A correspond to one another in ASCII, capital A. And then here, what I'm doing is I'm saying take this string, LED color, and then we just want to take a portion of it, right? And so we want to take, we don't want any of this RGB space and parens, right? And so we start looking, so we use the substring method, and we're saying LED color is now going to be a, a subset of the larger string, and we're going to start looking at it, 4 bytes in, so right after this parens, and we'll say then go up and take everything inside of there up to, but not including that last value. So it really all it does is it just gives us the information that we want out of the middle, and this becomes something that's flexible. So like these act as sort of like header and footer bytes that we can like eliminate. We don't need them. And then here I'm saying serial.write LED color plus new line. And so we can see this is the value that gets sent out to the Arduino. It's this string 0, 255, 0, followed by the new line character. The new line character is the flag in our sketch that shows us what's that we've got a complete data packet and to process it. So this is pulling data for New York. We can look at other locations. If we wanted to figure out, like, I know that if we were to look at like Delhi, which is unfortunately a typically the air quality there is not so hot. Um, so we can just go down, we'll change that up there. So this is my API request. So I'm no longer asking for New York, I'm asking for Delhi. And so now I'm going to go down here and I'm just say like the Delhi AQI. Yep, there we go. And I'm going to run this and hopefully it's something different. Oh, I did something. Uh, oh, there we go. Forgot to delete the A of US of A. And so we'll try this again. Okay, red. So the air quality index there is 152. You can see that it reflected on the LEDs here. So this is something that you could do that you, if you wanted to like have something that alerted you to the air quality outside, uh, then before you left in the morning, you could do this, right? Try experimenting with it. You could try with weather. You could hook up a servo motor and you could figure out if it's like rainy or sunny or windy, and then you could have a servo motor that then like adjusted and pointed to say like what it was, right? You had a piece of cardboard with a little arrow that point from like cloudy, sunny, windy, or what, snowing, whatever it is, right? But these are just examples of different things that you can do. I really encourage you to come up with something kind of weird and interesting. Um, there are other types of ways that we can communicate online and with microcontrollers that aren't necessarily network enabled, and we'll get to those in future videos. Thanks a lot.